All right, so we are on video 2, which is just the second half of the day 6 notes. If you haven't already, go ahead and pause this video and do the U-Try before seeing what the answers are, because I want to see whether you know or you need to see whether you know what's going on. So again, pause the video and then come back. All right, welcome back. So I need to figure out how many I squareds are in I to the 6, and there's 3 of them. So I'll rewrite it. 6 I squared, I squared, I squared. Replace all those I squareds with negative 1s. So I got 6, negative 1, negative 1, negative 1. And this is multiplication, so it's negative 6. On B, break it apart into a negative 1 and a 125. The negative 1 gives me I. And the 125 is not a perfect square, so you break it apart again. In this case, the best way is 25 times 5, which gives me 5 radical 5. Put it together, 5i radical 5. C, combining like terms, so 4 minus 3, 2i minus negative 3i. 4 minus 3 is 1. Cross the line, change the sign, plus 5i. All right, and then distribute. So 32i minus 16i squared. Replace the I squared with negative 1, so your solution is 32i plus 16. Okay, if you didn't get that, pause the video. Okay, see if you can figure out what you did wrong. Rewatch it if you need to, but we got to get those figured out. All right, taking it a step further, conjugates. Conjugates with I work exactly like conjugates with the radicals do. So this is exactly like Tuesday's notes, except instead of having square roots, we have i's. You're going to multiply the denominator by its conjugate, and because you do it to the denominator, you're also going to do it to the numerator, and it's going to make those i's drop out. So if we look at example 1, for instance, I don't want no peeping toms, no i's in my denominator or in my basement. So I'm going to multiply by the conjugate, 3 plus I. On the top, I'm just going to distribute. So I get 6 plus 2i. On the bottom, I'm going to distribute as well, but something funny is going to happen. The 3 times 3 is 9. The 3 times I is 3i. Distributing the negative I get negative 3i minus I squared. They drop out. That's what I want to happen. Okay? And then this being negative 1 turns the whole term into a positive 1. So now I'm looking at 6 plus 2i over 10. And although it appears to be finished, because 6, 2, and 10 are all even, I need to reduce it. So I'm going to divide everything by 2. And I get my solution, 3 plus 1i over 5. 6 divided by 2 being 3, 2 divided by 2 being 1, and 10 divided by 2 being 5. You have to be able to divide everything to do that. All right, so example 2, again, get the i's out of your basement. Okay, so multiply by its conjugate, 5 plus 2i. Okay, in the numerator, I'm distributing, so I get 10i plus 4i squared. And in the denominator, I get 25 plus 10i minus 10i minus 4i squared. Do a little simplifying. On the top, when you put in your negative 1 there, you get 10i minus 4. On the bottom, the middle 2 drop out. Putting in your negative 1 makes that a plus 4, and 25 plus 4 is 29. 10, 4, and 29 can't be reduced, so you're done. Example 3, same thing, okay, multiply by the conjugate, but of the denominator. Make sure you don't get confused and use the numerator. FOIL, so you get 8 minus 6i plus 4i minus 3i squared. FOIL on the bottom, 16 minus 12i plus 12i minus 9i squared. And do some simplifying. Replace the I squareds with negative 1s. Cross out those opposite terms. So up top, this negative 3 and negative 1 make a plus 3. Combining that with 8 gives me 11. Negative 6 and 4 gives me negative 2i. All right, here the negative 9 and the negative 1 gives me a positive 9, so 25. And that's the solution because 11, 2, and 25 don't have anything in common. And sorry about this all being one side of the screen, I'm learning. All right, pause it, try the U-Try. When you're done trying it yourself, hit play again. All right, hopefully you tried it yourself first. Multiply by the conjugate of the denominator. 4 minus 2i plus 4i minus 2i squared. On the bottom, 16 minus 8i plus 8i minus 4i squared. Those cancel in the middle. Negative 1, making that a plus 2 and that a plus 4. So up here I have 6 plus 2i, and down here I have 16 plus 4, which is 20. And like example 1, those are all even, so I would reduce it, so it's 3 plus I over 10, dividing them all by 2. Okay, hopefully you don't have any questions, but if you do, there are tutors available tomorrow, Mr. Ballinger before school and Miss Quinelli after school. Hopefully one of them can get you figured out. Okay, so a few things I just kind of need to point out to you. When you have a square root with a negative, you get I. When you have a cube root with a negative, you just get a negative. Because here, if I were trying to get that, it's 4i. Here, it's just negative 3. Okay, why does it work? Because 4i times 4i is 16i squared, which gives me negative 16, which is what I was going for. And here, negative 3 times negative 3 times negative 3 gives me 9 times negative 3, which gives me negative 27. Okay, so it's not an I when it's a cube. Okay, same thing, fourth roots, negative 81. If I tried to figure out what that was, the fourth root of 81 is just 3. So if I experiment with negative 3 times negative 3 times negative 3 times negative 3, I get 9 and 9, which is 81. I want negative 81. So if I experiment with I, 3i and 3i and 3i and 3i, I get 9i squared and 9i squared. So I get negative 9 times negative 9, which is 81. So this one, not possible. I'm not going to give you one of those, but I am going to give you both of those. So make sure you do not give me an I when it's a cube. Only give me an I if it's a square root. All right, send me emails if you're really, really lost. Otherwise, try to hit up the math tutor or help each other out. You got smart people in the room. I felt really silly talking to myself doing this, so hopefully it was helpful. And I will see you Tuesday, but your quiz is Monday, so study, study, study.